So today in Math 3, we're going to be looking at the closure property. Now this is actually a pretty simple topic. It sounds complicated, it looks like it might be complicated, but it's really not. Okay, so let's see what it says. It says when you perform an operation with a set, now a set could be numbers, it could be expressions, it could be polynomials, or whatever you want to use. Okay, and this unit, we're looking at polynomials. Okay, and if you're adding or subtracting or multiplying, dividing polynomials, and the result is in the same set, so if you add two polynomials, you get a polynomial, okay? It is said that that operation is closed, okay? If you do something and you don't get a polynomial, then it would be considered open, okay? So we want to figure out, are polynomials closed under addition, subtraction, multiplication, and division? In other words, when you add, subtract, multiply, or divide polynomial functions, do you always create another polynomial function? And that always is going to be a key piece of what we're going to be looking at. So let's look at some examples. We're going to do addition, subtraction, multiplication, and division. We're going to show you the integers, so just like numbers first, and then we're going to show you a polynomial example and show you what all this stuff means. Okay, so in your calculator, you got 437 plus 25. What does that give you? 462. So we started off with numbers. Did we get up a number when we were finished? An integer? Yes. Yes, we did. Okay. Now let's look at the polynomial example. 4x squared plus 3x plus 7 plus x plus 3. So if we combine the like terms, we'll get 4x squared plus 4x plus 10. Now we had two polynomials. We added them together. What did we get? Another polynomial. So this would be closed. Because we got a polynomial after we added the two polynomials together, it is a closed function. Or a closed operation. That's what I meant. Alright, so let's look at subtraction. We have 437 minus 25. So we had some integers. We subtracted those from each other. We got 412. So we had integers. We ended up with an integer. We're good to go. Let's look at the polynomial of this. 4x squared minus x. It's going to give you, 4x squared plus 3x plus 7 minus x plus 3. So the 4x squared has nothing else to be combined with, so we're going to rewrite 4x squared. You have 3x minus x, which is going to be plus 2x, and 7 minus 3 is plus 4. So we had two polynomials, we subtracted them, and we got a polynomial. So this would be closed, because you ended up with a polynomial from two polynomials. All right, next, multiplication. 437 times 25. So we have two numbers, two integers. When we multiply them together, we get 10,925. So we ended with another integer. That sounds good. Okay. Here, we're going to multiply these together. We could do the rainbow method. We could do the box method. Let's do the box method because I like the box method. So we're going to have x and 3 here. We're going to have 4x squared. We're going to have 3x. We're going to have 7. Okay, so if we multiply the stuff that are in intersecting boxes, we're going to get 4x to the third, 3x squared, and 7x. On the bottom row, we're going to get 12x squared, 9x, and 21. The diagonal pieces are going to be the pieces that are like terms. We're going to combine those as we bring them out. So we're going to get 4x to the third plus 15x squared plus 16x plus 21. So we had two polynomials. We multiply them together. We just got a bigger polynomial. So this would also be closed. Okay. Now here, we had division. 437 divided by 25. So we have two integers, 437 divided by 25. All right, we get 17.48. This is not an integer. Okay, so this would be an open. Now, you might be saying, well, okay, but if you use some other numbers, you could get a closed because it would work out nicely. The problem is, up here, we said always. Because there is an instance where you don't get something, it's going to be not good. Okay? So you might get it closed, but it's not always, so it would be considered open. All right, here we have 4x squared plus 3x plus 7, all right, divided by x minus 3, or x plus 3. So this is you can use synthetic division. We have 4, 3, and 7. All right, we're setting x plus 3 equal to 0. We get x equals negative 3. We have dropped the 4. 4 times negative 3 is negative 12. 3 minus 12 is going to be negative 9. Negative 3 times negative 9 is 27. And 27 plus 7 is 34. So this is a remainder, right? So it doesn't work out nicely. It's not a factor, so because it doesn't work out nicely, it would be considered open. Now we have seen others that you can, but again, we go back to this always. Okay, so division would be considered an open. Now there are some instances where it can be closed, but because it's not always, okay, we're going to have problems. So what do we notice? Polynomials are not closed under division. Okay, so some practice. So as a quick notes, I'd like you to try these practices. All right, it's the same idea as we had up before. You're given two functions. You've got f of x and g of x. And you have addition, subtraction, multiplication, and division, and show if they are open or closed. Just explain how that is. Okay? So try those out, and we can talk about this on Thursday. Yes, Thursday. All right? Good luck.